Yeah.
So the derivative, they're asking for a derivative here. So derivative of e is just e. So you start with that guy. And then the derivative of the exponent. And that's it. So the key here is to expand first. So expand and then do your derivative. So you're going to take the 2 and put it in front. And then you're going to use your rule of division and separate it with subtraction. And then you are going to just do your derivatives of your natural log. So we have 2, and this is derivative of the inside, so 20x cubed over derivative of just the function, 5x to the 4th. And derivative of the inside, 10x to the 4th over 2x to the 5th plus 3. I would simplify this before I tried to get common denominators. So like simplify your x cubed and x to the 4th, simplify your 5 and your 20. Nothing over here can simplify, so we'll just go with that. Then get a common denominator. So my common denominator is going to be x, 2x to the 5th plus 3. I still have this 2 out here I'll deal with in a second. I need to multiply the 4 by the 2x to the 5th plus 3. And I need to multiply the 10x to the 4th by the x. And then I'm going to just keep simplifying, so I'll distribute. So I'll have 8x to the 5th plus 12 minus 10x to the 5th all over x, 2x to the 5th plus 3. And I'll still pull this 2 out here. And then I will combine my like terms. Negative 2x to the 5th plus 12 over x, 2x to the 5th plus 3. Your answer key also pulled out a 2 here. So they have 4, negative x to the 5th plus 6. And the only reason you do that is to see if you could simplify it with anything else, honestly. I don't know that it makes it any simpler, but because some people would actually distribute this through once they saw nothing would simplify. So either one is fine. One, you are just going to do natural log because it's a denominator to the first power. You do need to check your derivative. So your derivative here is 2, and you have a 2. We're good. You can pull that negative out. So you end up with a negative pulled out, and then you have natural log of 2x plus 6 from negative 7 to negative 5. And I have an extra guy there. And then just plug it in. So I think when you plug it in, you're going to get 0.693. But you'll just plug in your negative 5. So negative natural log of remember it's absolute value, by the way. So this is absolute value when you do that. So this is going to be negative 10 plus 6. So natural log of the absolute value there, you're just going to have log of 4 because it would be negative 4, but it's absolute value. Minus, and don't forget you have a negative here, negative natural log, plug in the 7. So you would have absolute value of negative 8. So like that. This is how we get the plus there, because remember you subtract when you're doing definite integration, and you get 0.693. Antiderivative of e is also just e. You do have to consider your exponent here. My exponent is 2x cubed plus 1. So my derivative of that guy is 6x squared. So it's all taken care of in itself. I don't have to worry about any u substitution corrections, so to speak. So my antiderivative here is just going to be e to the 2x cubed plus 1. And then don't forget you have a plus c because it's indefinite integration. So for this one, when I look at this one, my exponent is 3x cubed minus 5. If I did the derivative of 3x cubed minus 5, I would have 9x squared, and I need 45x squared. So that means I'm going to have to multiply my answer by 5. So I have to say, well, it's going to be 5 times e to the 3x cubed minus 5 is my antiderivative here. For this one, we're going to look at the same thing like we just did for that one. We're going to look at our exponent, which is x plus 3. And my derivative of x plus 3 is just 1, and I have a negative 3 here. So that means my answer is going to include a negative 3 times e to the x plus 3 taken from negative 5 to negative 3. And then you just plug it in. So you have negative 3 e to the 0, which is just 1, and then minus negative 3 e to the negative 2. And they solved it all, but if you plug it in, you're just going to get that guy right there. They got a common denominator and all that good stuff. If you look at what they did, we have negative 3 plus 3 over e squared, and then they got a common denominator over e squared. That's how they got the answer they got, by the way. So for this one, they say it doubles in 24.8 minutes. So we have y equals p e to the rt, I guess, right here is what we're using, continuous. And so if my initial condition is like x, right, that's my p, my final, when it doubles, is 2 times x, right? And then I have times e to the r, which I don't know, and the time I know is 24.8 minutes, okay? Make sense? And so if I were solving for r here, my x's will cancel, because if I divide both sides by x, I just get that, right? So I end up with 2 equals e to the r 24.8. And then to solve this, I'm going to take the natural log of both sides. On the left-hand side, obviously, I just have ln of 2. On the right-hand side, these cancel. And so I just have r times 24.8. And so my r ends up being ln of 2 divided by 24.8. Okay? And so now they're asking what happens, or how long does it take for it to triple? And I'm going to conceptually do the same thing that I did here. Well, I don't care. My initial is x, right? My initial population. So now I'm looking at 3x. And I have e, and now I know my r. My r is natural log of 2 divided by 24.8 times t, which is what I'm solving for. And so then again, my x's will just cancel because I divide by x. So basically I have 3 equals e to the r, which is this crazy thing here. I'm just going to leave that alone till the very end. And so I'm going to solve the same way. I'm going to do the natural log of both sides, right? On the left-hand side, I have ln of 3. On the right hand, my ln, my e cancel. So I just have ln of 2 over 24.8 times t. And so the rule of fractions, I just multiply by the reciprocal, right? So if I multiply this by 24.8 over ln of 2, that's going to cancel. Multiply this by 24.8 over ln of 2, and then you can just plug that thing in and you get 39.3 minutes. Derivative of this guy is 15. There we go. X cubed over 1 plus, and you're going to do this guy, the whole thing, squared. And so you're going to, and then just simplify this guy. So we have 15 x squared over 1 plus 25x to the 6th. You cannot simplify that anymore, so you're done. You have to think about your properties of exponents here when you do this one. So when you have like bases, when do you subtract your exponents? At what point with like bases do you subtract exponents? Division. So you could write, I could rewrite this guy on the right to be 3e to the x over e to the y. Because that's e to the x minus y. Does that make sense? And so then when I'm doing this, of course, I want to do separation of variables, meaning I want my y's with my dy and my x's with my dx's. And so that's what I'm going to do. I'm just going to multiply the left-hand side, both sides by e to the y. So I have e to the y dy, and then multiply the other side by dx. So 3 e to the x dx. And then antiderivative. So if I do the integration of both sides, integration of e to the y is just going to be e to the y. And then integration of e to the x is just going to be e to the x. So I have just e to the y equals 3 e to the x plus c, right? I do need to get y by itself. So my goal here is to do, how do I get rid of the e on the left-hand side if I'm trying to get my y by itself? How do I get rid of it? Yeah, natural log of both sides. So on the left-hand side, I have y, and then I have natural log of 3 e to the x plus c. And that is your answer. So we have dy, ignore this guy for right now. dy dx equals x over y squared. We're going to get our y's with our dy's and our x with our dx. And then we're going to do integration here. So we're going to get 1/3 y cubed equals 1/2 x squared plus c. So we want to solve for c, and they've given us an initial condition. And so we're going to take this initial condition and plug it in. We're going to plug in a 2 for our x, and we're going to plug in cubed root of 7. There's a reason they gave that to us for y. So we have 1/3 cubed root of 7 cubed equals 1/2 2 squared plus c. So I get 7/3 equals 2 plus c, which means I can just subtract 2 or subtract 6/3. So c is going to equal 1/3. So my function is going to look like this. Y cubed over 3 equals x squared over 2 plus 1/3. And then I would multiply everything by 3. I'm trying to get y by itself here. So I'm going to multiply everything by 3 to get rid of that 3 over here. So I have y cubed equals 3x squared over 2 plus 1. And then just take the cubed root of both sides. So I'm going to come up here with my answer. So y equals the cubed root of 3x squared over 2 plus 1. Or you could say 3/2 x squared plus 1, but that would be your final answer there.